Bet next time I try. And even if I still can't do it, yeah, you know that I'm gonna stick to it. Yes, it's all about going through it, and I'm gonna tell you why. Whoopsie, whoopsies, I made a mistake and it's okay. It's okay. Whoopsies are what it takes to get better and better every day. Whoopsies, I made a mistake and it's okay. It's okay. Whoopsies, help me look, see, I'm better at this today. Woo! Whoopsies, whoopsie, whoopsie, whoopsies.
I'm a little embarrassed when I look at my drawing compared to this. I'm just not getting anywhere with this. It makes me wanna hide. Aw, don't be embarrassed. Don't hide.
You should have seen mine the first time I tried. It took a lot of whoopsies to look this way.
No one's perfect on their first day. Whoopsie.
Whoopsies, I made a mistake and it's okay.
It's okay. Whoopsies are what it takes to get better and better every day. Whoopsie, 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 whoopsie.
Well, what about this? I want to jump rope, but nope, I just can't do it.
Well, not yet. Come on and practice with me. You'll see there's nothing to it.
Whoa! Whoopsie.
Whoopsies, I made a mistake and it's okay. It's okay. Whoopsies, help me look, see, I'm better at this today. Woo!
It was only a dream, the waves of evil crashing over us. It was only a weak and faithful scream beneath the battlements. I know it's hard to follow before it's too long. Wake up, my love, please don't give up on me. It's hard. Wake up. It was only a dream, the waves of evil crashing over us. It was only a weak and faithful scream beneath the battlements. But I know it's hard to follow before it's too dark. Wake up, my love.
What is up, you guys? What is up? We are back at it again. Another day here at the grind, exploring more of the sewer depths of programming. We are all going to get very accustomed to trash together, alright? We're all going to be trash together. But it's alright, because we're going to get through it together, alright? Together! Alrighty, are you guys excited? I know I'm excited to continue on here on our journey today. But before we do that, let's tell you a little bit about ourselves, shall we? Great idea, great idea. Alright, so if you don't know, we are Rootkit, a nonprofit here in the US of A. If you go over to our site, we like giving away things for free a lot of the time, alright? Including this class, which if you go to college, $100,000 easily. You go We used to charge $20,000 for this class. We're doing it for free, all right? Other coding boot camps, they don't teach you nearly as much. It's so low qual, it's insane. And they charge anywhere between $15,000 and $20,000. We're doing it for free. Don't get scammed. Just come here, all right? Additionally to all this free stuff, we're doing a free giveaway. Our week 6 giveaway is here. It is live. So make sure you go over to the site and enter to win. All right. You just got to do basic things. All right. Basic things like subscribe to our YouTube channel, follow our Twitch, and a couple other tasks. All right. Very basic. Nothing that costs money. Now, if you like what we're doing and you want to help support us, you can head over to this link, and I guess I was wrong. Apparently the links have been working. I don't know. All right. Sometimes I get confused. Apparently the links on all of the streams have been working perfectly. So if you're on YouTube and you click the link in the description below for the 100 Days of Rootkit Streamlabs charity link, you're able to get to this site. You can donate here, which we need because doing things for free is not cheap. All right, we can't keep going forward if we don't have generous donators. Additionally, if you donate, you can unlock certain rewards like our stickers, our awesome collab t-shirt, and this epic hoodie I got on right now. Look at this. Oops, there we go. Oh, there we go. Little emblem here and the Rootkit logo on the back. I love this hoodie. All donations are being matched 1-for-1 by an anonymous donor for the first 10,000 donations. So if you donate, it's like you're donating twice. It's super awesome. We have a bunch of pillars that you can hit along the way, like 24 hours streaming straight, 10K shaving my head here live on stream, and the one we don't really want to mention, but shaving my beard, no one really wants to see that anyways, right? That's a little too extensive. So we can forget about that. Alrighty, how are you guys doing? Let me, where's my, my chat? Here we go. How are you guys doing today? Let's see here. Posted the challenge in the Discord as I understood, but didn't receive feedback. Can you please let me know if I did the challenge correctly? Did you? You had to just post. Did you just post it now? Because I saw Evox and we talked to him about it. Oh, okay, I see. You just posted the one if statement. Let me see here. So when you post your code, I don't know if you're just trying for this one alone, because this one alone is not right. None of this is right. This is an even valid Python format. So if you're posting your code in here, make sure it's formatted correctly, because I can't really grade that. But from what I see right here, statement wise, no, this is not correct. Don't worry, we're gonna go over it here actually in a couple seconds. Yeah, I saw Evox. This one was not 100% correct either. It had a bug in it, and I guess we'll talk about that, which yours also has a similar bug. But he has a clever way of doing looping. I don't encourage that method, but it's very inventive. I like it. All right, I like it. It's creative, and that's the thing. What I told him here and what we talked about the stream last time is, it's like a blank canvas. You're an artist. You just paint away, all right? There's no wrong way of doing things. There's only more better or more correct ways, but nothing is actually labeled as the correct or perfect way, because everything is always gray. All right, let's see here. Yeah, was that what I was supposed to do for the challenge? You're getting close to it. We're gonna go over it right now. Let's demystify this challenge, shall we? And does anyone else want to ask any questions or turn in their challenge last second? You got like 10 seconds. Go. All right, so let's talk about it a little bit. Specifically, let's go over what we got here from evoc, since it's laid out correctly so I can just copy and paste it, I'm only going to be doing the logic block. Alright, so this is what you guys need to do, specifically add the logic in here. So I'm going to comment the base challenge and just paste the if block he sent down here. So let's kind of run through this, shall we? This should work because they're using the same variable names as us, so we can just paste it in and it should work. So let's see what happens here. So if I run this and I enter in a number, let's say 1. 1 says I guess too low. Alright, pretty sweet. Let's rerun this again and say 10. 10 says I guessed too high. Alright. Let's run this again. 100. You need to guess between 1 and 10. Okay, good. It's keeping the bounds there. And let's say -1. -1 said I guessed too low. So it's not covering that lower bounds there. Alright? Not covering that lower bounds there. So it's close, but not 100% of the way there yet. So that's a little bit of a bug, but we'll go over and how to fix it and how I would, the 2 different ways you can go about doing it. I guess there's technically more than the 2 ways to go about doing it, but we'll show it off. All right. Are you guys ready? So let's see here. So the hint was the logic should go right here. So we can solve this, like I said, by 2 elif statements. All right, 2 elif statements. The pro gamer move would be trying to do it in 1. So let's see. If we do a new elif statement, so with the to method, we know that we want to keep them in the bounds of 1 and 10. All right, that's the upper and lower bounds of our game. So what we can do here is the user input, if the user input is greater than 10. So that was correct from evoc. All right, that is a correct way of doing it. And then you can print, what do you call it? Let me go and grab what he said here. I'm gonna steal some of his stuff because in programming, stealing is good. So I'm gonna steal what he said here. You need to guess between 1 and 10. And I'm going to then put another one here and do greater than 10. It's less than 1. All right, less than 1. This is going to cover the upper and lower bounds. How is it going to cover? So remember, this is a step-by-step process when you're in a block. So it's going to look at this first one and see if the numbers are equal to each other. If they are, you won the game. All right. Then the next one is going to see if their number is greater than 10. If it's greater than 10, they've guessed way too high. That's not even in the playable number range. All right. So they're not allowed to do that. Now this one is going to be protecting us from the low end. All right. Numbers that are too low. That's not in the playable range. So if their input is less than 1, all right. If you look here and you were confused, that means in English less than. All right. Whoops. There we go. Less than. Let me zoom in. There we go. Less than. So this is if it's less than 1, they guessed way too low. All right. And then this is our normal logic. So now if we see here, if we run the game, if we say -1, it says we need to guess between 1 and 10. All right. If we try to do 11 now, we need to guess between 1 and 10. It does not like it. Now if we guess, let's say 9, you guess too high. All right, the game is actually running and playing now. And if we rerun this again and say something like 2, you guess too low. And I guess one last test, we might as well just test the if we got it correct, which our number right now is 7. Bam, 7, we won. Sweet. So this would be one of many answers you can do in order to get the proper logic for this game. Any questions on that? Was that confusing at all to anyone? Checking the chats here. Y'all did really, really good. I'm very impressed. All right, sweet. So, what's the pro gamer move here, all right? How would you do it even better? So, the first thing that's wrong here is that, yeah, I think for your, if I saw right here, for yours, you were good on this one, but this one right here said 0. Was it different on this one? No. But this one's 0. 0 will cause an issue because, what do you call it? Because you can guess 0, and 0 is not in the playable range of 1 to 10. So just a very, very small minor bug there. Also, it might be a little hard for people to read that. I know it's a little hard for me. No, you were really, really close. You guys were all really, really like close. You guys all did really, really good. Like I said, I'm very, very impressed. We have to do 1 because this is less than 1. So if I put a 0 in, if we do a 0 right here, you'll see, whoops. If I do a 0 right here, you'll see that it's covered. But if I put a 0 right here, well, 0 isn't less than 1. So if I do a 0, that's now in the playable range. Yeah. Yeah, I know. You guys did really good. You were really close. All right. So what's the pro gamer move? So there's this concept in programming that's very, 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 very important. On top of all the other things I've told you is very, 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 very important. This is the thing that all beginner devs do, and you guys will do it also. It's okay. It's fine. Try to not do it. Try to force yourself away from it, because that's how you know you're evolving to the next stage in your dev life. It's this concept of dry. I need you guys to be bone dry, desert dry, all right? Super extra dry freaking wine, all right? Dry. It needs to be dry. Your code needs to be dry. What does that mean? Dry stands for don't repeat yourself. DRY. Don't repeat yourself. Don't repeat yourself. If we look at this code, we can see somewhere specifically where we're repeating ourselves. What do I mean by repeat ourselves? Where things are literally exactly the same. Now, this of course comes with its own, it depends. And there will be times where code is very similar or pretty much the same. But that's not the big issue. The big issue is we got this line here and this line here, which is the exact same lines of text. Also, we have this line here, which specifically this 1 in 10 here is the exact same stuff. Now, when your code is small like this, it's not that big of an issue. What's the issue, say? Let's say you want to change the game. Let's say you want to make it 1 through 100 instead. 1 through 1,000,000. A negative 1,000 to a positive 1,000. Every time you want to make a modification, you need to now grab your trusty mouse and go everywhere in your code and make that change. I gotta click there, I gotta click here, I gotta click here, I gotta click here, and change this one right here, and this one I need to revert back so it works. Holy crap, that's a lot of clicking, a lot of work, and it gets worse because this is a baby program. This is small, this is not much. Programs will easily go into tens of thousands of lines of code. You don't want to have to go through those tens of lines, thousands of lines of code to make a small change like that. So we're going to go through a couple different steps on how to make your code more dry. So the first way I would go about this is changing our logic here. All right. And we're going to introduce a new thing. All right. A new term here. 2 new terms. And or. All right. And or. If you are familiar with English, you should be familiar with and or. what they mean in English is exactly what they mean in programming. There is no trickery here. It's the exact same thing. So instead of having these guys as separate, we can instead copy our logic from this one, completely remove this. So now we don't have two of the same print statements. All right. And we can now instead go right here, do a space and say and that. All right. So now this will only run if user input is greater than 100 and user input is less than 1. Wait a second. That doesn't make sense, does it? Because user input can never be greater than 100 and also less than 1. So make sure you are speaking these things out loud. Again, say your if statements out loud, for God's sakes. Say them out loud, because that will show you the flaw in your logic. You know, when you just look at these symbols, it may not make sense, but when you say it out loud and you hear yourself utter the terms, it will make sense. So instead, we don't want an and there. Maybe we need an or? I don't know. Let's type in or here and let's say it out loud. If user input is greater than 100 or user input is less than 1. Okay, there we go. That's what we want, right? That's what we want. If, let me change this back to 10 because that's what we had before. So if the user's input, what they're giving us, their number they're guessing is greater than 10, that's not a valid number, or it's less than 1, which is not a valid number for a game, you guessed, then we can say you need to guess between 1 and 10. That is the proper logic. That is the pro gamer move. That is what you may want to do in order to compress things, make it more dry, because things are compressed. You don't have multiple of the same print statements, etc., etc. Does that make sense? You guys tracking on that? So ands and ors can be done unlimited amounts of times. So I can do a space here and say an and, do some more logic, and then do an or, and then do some more logic, and then do an and, etc., 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 forever. So utilize them. Also, one last thing. For your logic here, we've talked about in normal math, and then we talked about in basic math in regards to I'm forgetting, why am I forgetting the terms? We just went over it. But the logic we went over these things called order of operations. What happens first? Pretty much it's always things inside of the parentheses happens first. Same thing here in programming. If you want certain logic to happen before other logic, you can wrap it in parentheses in the if statements. All right. So you can now do compounding logic like and have parentheses in here. And then I can say something like, I don't know, false. But you can basically have different pieces of logic compute before other pieces of logic compute. All right. This is a way to force the order of operations. Again, this is why we brought up things like truth tables. Let me bring up here. Truth tables. You guys remember truth tables from basic math that we talked about? Because truth tables are literally ways that you can go about computing this stuff. All right. Because we had ands, we had ors, we had these things called XORs and NOTs. All right. We can do XORs also in here. And I guess you guys are going to learn another term, NOTs. You already know NOT. You can literally type in NOT. What does a NOT do? Come on. You're smart. I don't need to re-explain this to you. You took basic math, right? No, you're watching on YouTube later. Guess what? Go back. Go watch basic math. All right? Go watch basic math. As you can see here, we can also do nodding. All right? We can do the knot of things. We can make things very naughty if we want. Why are we able to do stuff like this? Because it's hooked into the underlying hardware. because the underlying hardware is capable of doing these things. So we're just harnessing that power here in software world. All right. Any of the topics we went over in, in basic math, we can do here. We can do yeses and nots. All right. Yeses would be your truths, nots, reversing that truth, ands, ors, XORs, nans, nors, and XNORs. All right. You can do all of these. Truth tables are important because if you're working on a complex problem, you can break these out to see what all the potential possibilities are. If you can't just think of them yourself, because sometimes they get pretty complex. Also, that's where the one thing I'm forgetting also comes in handy, because depending on what you're doing, let's see here, GitHub, rootkit.org, comp.sci.cert, basic math, our sets, there we go, our sets and relations. So this is where things, absolute complement, relative complement, etc., are literally what you're doing when you do these if statements, these logic statements. You already did it. You already did it with your is greater than, is less than, is equal to. You have now done this stuff in programming. So hopefully things will start making a little bit more sense. Before, we had these sets or lists of things. When you say if a number is greater than, there are lists. Your universal list is going to be every number infinitely possible. All right? Any number. You specified integer, so it has to be a whole number, of course. So any infinite number of whole numbers. You have built logic to protect from a number all the way up infinitely and another number down infinitely. Those are different sets that you're protecting against. All right, so bring it all around. We'll revisit this concept a little bit more moving forward, but those are different ways. Truth tables and sets and relations are different ways for you to visually see and understand some of the logic if you're working on more complex problems where it might help with that type of abstraction. All right, any questions on that? All right. Welcome back, Kwai. So let's move forward here. So today's about loops. We're going to get into loops, all right? All about that feedback loop. So let me see. Was there anything else that I wanted to say before we get into our loop-de-loops here? I feel like there was, but oh, so the other thing that we could do, and this is more of a pro gamer move, all right? This is more of a pro gamer move. We can do things like this, all right? We know, because we have 1 and 10 here and a 1 and 10 here, and we may want to change this at a later date. So what can we do to make this more dry or dynamic? Well, we know for a fact where we want our game to start accepting input and where it can go up to, the range of it per se. So we could do some things very simple here. We could say literally lowest number and highest number. And we can say the lowest number they can do is a 1 and the highest number they can do is a 10. All right. So we're saving these off here as part of our game, just some more extra variables. All right. And we can now do stuff like, instead of saying a 1 right here in our if statement, we can replace that with the lowest number. And for the other one, the 10 right here, we can replace that with the highest number. Additionally, we can actually embed variables inside of strings, right? Inside of strings. Super convenient. There are several ways we can do this. The most convenient way is going to be if we just delete them and replace them with curly brackets. All right. We got to do an extra step here, so don't worry. But we can replace them with curly brackets. And then at the end here, we can do a dot format. This is a new function we're going to do. Special thing here, though, we need a dot format. And in here, we can say lowest number, comma, highest number. Yes, this is going kind of fast. Don't worry. I'm just going to show you guys this. We're going to get more practice with it. I'm going to show you guys this really quick. And then we'll continue forward. We'll revisit this. Don't worry. So now I can do, this is more so the conceptual point, and you guys can mess with this a little bit on your own free time if you want. So now we can replace this here. So now when we have and it looks like this may error out because I did something wrong here. We'll figure it out here in a second when I run it. So now our code is more dry. If we want to modify our game at all, we don't need to change everything, go through and click everywhere. We got two little setting knobs. You ever go to a video game and open up the settings and then change the setting sliders in there? This is what they're doing, right? Or in a game or an app. You ever go to Discord and go click on your settings over here? And what are some settings I can click on? I don't know, appearances. Here we go. You ever mess with these settings? This is what they're doing. They are making everything in their code like this and putting these little knobs at the beginning. So that way you can easily edit them and it will affect the rest of the code everywhere else. So if I want to now make the game 1 through whatever that number is, now it just works. It just works like magic. So if we run this, now you can see right here, let me stop this, clear, rerun so it's a little more clear. Now you can see it just shows up there like magic, and I can do some weird higher end number and it now works. All right. If I still do -1, it will still do the, that is not correct. So, oh, whoops, sorry, because I messed with this. This is why it was graying out, because I messed with this stuff to show off ands and ors. There we go. Perfect. There we go. So I'll run that. So now if we do -1, you can it still says and prints that error message, but that error message is now formatted correctly with our new numbers, our new logic. So it's very, very convenient and very, very useful. So another way so remember, if you want to use this, we're going to go over it many, many times moving forward. If you want to use this, curly braces, where you want to replace stuff, dot at the end of the string format, that is an action you can take. The dot, don't worry, we're going to dive into why the hell that's even there in the first place later on. Lowest number, and you basically, it's a comma delimited list. So you just put commas after every little thing you want to add in. So right here, there has to be a 1-for-1 relationship too. So we have one thing here, which means it will be linked to this one. We have another thing here, which means it's going to be linked to this one. If we have another thing, it will be linked to the next one on the list. So going from left to right, it will match up with whatever these variables are left to right. Now, if that's too confusing for you, I'll show you another thing you can do. Little bit easier to understand. All right, this is the better way to do it. This is the preferred way. You should do this if you ever have to do this. But for beginners, this might be a little too much. So let's look at another way we can do this for the strings, that is. Instead, we can do 2 more quotes and pluses. All right, pluses, and right here we can say lowest number, and then right here we can say plus plus, and then highest number. So this is another way you can do it. You can put the variable right here. You have multiple strings now, and you're just adding all those strings together. So if I go ahead and take this and paste it right here. I don't need this last one. And if we run this, I think this will, also throw an error. So this will throw an error, all right, by default. What is the error? Well, come on, let's read the error together, shall we? Type error. We've come across those before, all right? Can only concatenate string, not an int. What does that mean? Concatenate. Concatenate means add together, bring them together, stitch the strings together, make two sentences into one sentence. It can't do that with numbers. So what do we do here? Are we just screwed? Well, no, we can cast them. We learn about that. We can force them to become strings. So if we do it this way, we can now force them to be strings. Like I said, I don't really recommend this. You can do it this way. It's kind of easier visually to understand what's going on because you have just the sentence right here and it's perfectly in order and everything that you want is literally in that order. But it's a lot more work, as you can see. All right, so I just want to show that off. We're gonna get into that a little bit more as we move on. But for now, I'm gonna change it back to the format method, or should I remove it completely? I'm gonna remove it completely for now, just so we can focus on while loops and we don't need to get stuck on the printing. But I highly recommend you guys to use the format here moving forward. When we make the while loop here, I'll go back and reformat everything, and then we'll go over formatting again, just in case any of you guys were lost on that. All right, so let me fix this. So we got our logic here now nailed down. The only annoying thing about this game is you have to run it again and again and again. Also, the number they need to guess always stays the same. It never changes. Like, this is a pretty lame game. It's a one-time playthrough, no repeatability, all right? And we want our users to be addicted to this game, all right? Because what is a good game anymore if it's not addicting like heroin, all right? Those are the only games that come out anymore. We need our users to be addicted, and we need to put in lots of microcharges. We need them to pay 10 cents for this, 50 cents for that, and $1 for that. All right, we got to make money. That's what we're out here to do. All right, we don't care about nothing else. Screw their souls. All right, we want them to be snorting our game heroin out here. All right, so we need this to loop. We can do looping in programming, and there's two types of loops. All right, two types of loops. Can you slow down a bit, please? Yep, I can definitely slow down a bit. So we're going to go over formatting again here in just a second. So if you are lost or confused about formatting or string stuff, don't worry, we're going to go over it again. For now, we're just going to move forward with our looping here. So loops, there's only two types of loops in most programming languages. Some programming languages only have one. Some have technically like 3. It's usually just 2. All right, why would you use one loop or the other? That's a great question. Let's talk about the first loop, while. The while loop. All right, the while loop is literally the word while, and the word while, this type of loop, means go forever, never ever 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 stop, to infinity and beyond. Well, kind of. It will go forever until a condition is met. So this is also a special statement in Python that can accept a condition. What else do you know can accept conditions? If statements. Correct. If statements also can accept conditions. So let me, to explain while loops, we're going to make a new file so we can kind of get this jumble, this mess out of here, and we can just focus on while loops. All right. I'm going to call this loops .py. All right. New file, loops.py. So we can just focus on loops. So while loops, very easy to make. If we say while, and after we say while, it's formatted just like an if statement because it requires a condition, right? What is our condition right now? I don't know. Let's make it true. So So what does this mean? This loop will go forever and never ever stop, period, until our computer explodes. Why are we going to do this? Because I want to sacrifice my computer for you. Not really. I'm going to show you guys what happens when you get into an infinite loop, but also how to stop it, right? Because what's the fun if I just don't put myself in danger and just tell you how to solve it? All right, I gotta put my computer on the line here and show you guys how to stop this potentially dangerous thing that you will do over and over again on accident. Trust me, you even do it when you're pro. All right, so we're just gonna go ahead and print in here. Hello. So while it's set up just like an if statement, you say while some type of conditional. So we put true because everything evaluates down to true or false, 0 or 1. You could also do something like is 1 equal to 1. All right, we're just going to do true. And remember, you have to add a but at the end of it, right? A little colon. All right, you have to, this is true for every conditional statement. All right, we have to add a little but at the end. And since we're doing this and adding that little but, that means the next line underneath it needs to be tabbed up, because what needs to loop? All right, we need to tell it what code we want it to loop over. And we can see this visually if we say end right here. This will never actually print out because this loop will never end, at least right now. And we'll do another print here that says start. So again, anything that's tabbed up will be a part of this loop. It will be looping forever. So let's put my computer on the line here and see what happens. If I click play, what is going on here? Ampersand, character is not allowed, reserved. What the hell? Line 1, character 2. There's nothing there. Oh, there was something on the command line. Let me rerun this. There we go. It's going forever. It's looping forever. If I try to scroll up, it doesn't even go. My computer is bugged out right now. Let's pull up Task Manager and let's see what's going on here. Oh no. Hopefully, there we go. Woo! My God, look at our program go. We're using 20% of my CPU's power right now. Our program is intense. It is wild. It is crazy. Please do not run this right now if you're watching. Until I go over how to stop it. It is wild. It is intense. All right. It's going to keep going. It's probably going to bog down your computer. All right. There are several ways you can stop this program. Remember, we're all about cancel culture. All right. Remember cancel culture when we talked about PowerShell and Unix? That's right. It's built into the programs. All right. It's built into your operating system. Hold down Control and C. All right. And that's how you can cancel the shit out of this program. Let me jump. There we go. And we canceled it. All right. Control C is your savior. Control C, Control C, Control C. Use Control C whenever to cancel things. All right. You got the power. All right. You can cancel whatever you want. And remember, this is a forceful operation. It's going to force the program to cancel. This does not work all the time. If for some reason, let me go ahead and rerun this chaos. If for some reason this does not work and you click Control C, your next option is to, at least in Visual Studio, click on X here and close this out. That will remove your terminal session. If I reopen terminal session, okay, that's not removing the terminal session. Click on the kill terminal button, the trash can here. The trash can here will kill the terminal session. So if I reopen it, you'll see it's completely gone. If you're in PowerShell, click on the X. If you are in Windows Terminal or a Unix terminal, click on the X, close it. That's the next step. So if Control C doesn't work, which it should work 90% of the time, if it does not work, click on X. If that doesn't work, then guess what? There's a button on your computer, usually has a light on it. Some people call it the power button. Click that and restart your computer. Or kill tech 9. Yeah, kill tech 9 it. I like that one. You could also do that. No, that's a legitimate thing. You can, I guess I missed that one. So if you bring up your task manager on Windows, you can also try to end the task. This is like kill tech 9, or if you're in Ubuntu or Mac OS, you can kill tech 9 the process. It's a great thing to bring up, Kamal. He's been listening. He's been soaking in this information. Great point. And if you see here, when I don't have Chaos running, I'm sitting at 0% CPU usage. A lot different, right? A lot different than before. That program won't run for me when I try. I know we're not... Okay, you can run it now because I told you how to do it. You guys can run it now because I told you guys how to cancel it, all right? So now you can keep your computer safe, because my main concern is that you guys would run it and and you wouldn't be able to stop it, and the stream would get messed up for you and your computer would burn. Mayday, phew, the day has been saved. So while loop. The important thing here is while loops will go forever until a condition is met. If we have true here, your condition will never be met and it will never end. So let's maybe see. You gotta help me out here, Koal, a little bit. You gotta have this on different lines. You gotta put it on different lines here, because it's really hard for me to help you out when it's a one-liner like that, because again, Python is white space sensitive. So when I try to copy and paste this, it's going to yell at me because it's all on one line. So how do we maybe control this? Because we're doing all chaos mode right now. We can control it by doing a condition and making it stop. So let's say start equals 1, end equals 10. All right, this is where we want it to start and we want it to end, and we're going to have it count. All right, we're going to build a little counting program. So count, and we're going to start counting from 0. All right, so if you send it to me like that, then this is not going to run because you have these extra spaces right here. Also, while is right here. Here, if you want this code, you can take it here, but you really gotta, I don't know what you're doing or how you're pasting that, but there you go. You can copy and paste that. That will work. All right, sweet. So let's make this run for just a set amount of time, a time that we've dictated. All right. So while count is not equal to the end. All right. While the count is basically how much we're counting by, we're going to count by 1 every single time. If our counting hasn't reached this final number, this number of 10, then keep looping. All right. That's what we want to do. In this print, instead of putting a string there, we're just going to print our count. And I guess start is kind of useless right now, so we're just going to remove start. That was a mistake. So if we run this now, you'll see that, oh, sorry, don't run that. We'll see that we didn't finish our logic here because we're not actually counting. We're not actually increasing our count. So how do we increase our counting? Well, we can do that by saying count equals itself plus 1. We're doing some math here, all right? Because remember, variables are just placeholders for some type of value. So count, at least at the beginning, is a 0. So 0 plus 1 equals 1. And we're going to save that off into this variable. We're going to replace what was originally there with this new data value. So if we rerun this, you'll see that we're starting 1, 2, 3, 4, 5, 6, 7, 8, all the way up to 9, and then we end. All right, then we end. And you can see print end goes here. Again, anything that's tabbed up will be looping inside of the while loop. Anything that's not tabbed up afterwards, so the first thing that's not tabbed up will break that loop block, right? So this is pretty neat. Why did it stop at 9? That's a great question. Because it stops when this becomes, becomes false. So if count is not equal to end, which 0 is not equal to 10, then it will loop. And it will keep looping whenever things are fake news. Whenever things are true. And it will only stop and quit when things become fake. All right, when things become a lie, when the truth is no longer there. All right, when that is there, aka because our count happens after our print, so we're going to print 9. Count is going to get another 1 added to it, so 9 is going to become 10, and then it's going to loop back. That's why it's called a loop. It's going to go from the very bottom line and loop all the way back to the top here, and then it will do this logic again. Well, this is 10 now, and this is 10, so it's going to be like, I'm out of here. I don't mess with lies, all right? I don't mess with lies. It will quit and go to the end. So that is why we're not going to see 10 print out here. There are 10 numbers in total, though, because remember, you're in programming world, so we start counting at 0, right? So 0 to 9 is 10 numbers in total. Any questions at all with that? So while is very useful. Specifically, you can go ahead and drop your questions in that you guys have. Also, if you are a Patreon or Discord premium member, I am in the events chat, so you can just jump in there and chat away. So why is while super effective? Because it will run for a unknown amount of time, potentially unknown amount of time, up to infinity until a condition is met, which is great for games. Every game you've ever played is using a while loop. That's how the game engine keeps rendering every single frame. That's how you know whether a level has ended or not. While loops power every single thing that you do on your computer, on your phone, etc., etc. All right? They are one of the founding blocks of programming. You've learned if, else if, and else. Those are all fundamental blocks. You've learned while loops, another fundamental block. That's almost actually all the fundamental blocks of every programming language ever. We're almost done with all the fundamental building blocks of every programming language. I know, programming languages are small. They're very little. There's just like if you go to the hardware store, Lowe's ain't that big. I mean, yeah, it's a big store. Home Depot, whatever you go, whatever your local hardware store, there's only like, I don't know, maybe 10 to 50 tools you really need for completing most tasks. You want to build a house, 10 to 50 tools, you can get it, whatever you want to build, you can build it. All right, same thing with programming. There's a very small amount of tools that you'll need, and then you can go about becoming a programming god. I think Quake 3 engine uses 4s. All right, we'll get in 4s here in a second. That seems like a lot going on and all happening super fast for programs to run games. Yes, it is. Can I def hello string hello? Yes, you can do that if you would like. You can 100% do that. We'll get into functions here in a little bit. So when count starts at 0 and equals count, it will add 1 until the count is, yes. This is just going to take what the current value of count is and add 1 to it, and then save it into count, replacing what the old value was. So if the old value was 0, so if this is 0 right here, it's going to add 1 to 0, and now you have 1. And then it's going to save 1 into this. And now if this is 1, the next time it loops, this is going to be 1 plus 1, which equals 2. And then it's going to save the number 2 into count. So it's going to be rewriting that count variable over and over and over again. Alrighty. So while loops are really good when you don't know when something is going to end, potentially. It replaces and saves it because it's indented. Yes, it is inside of the while loop because it's indented up. That is correct. It follows the same logic with the if statements. It all has to be indented up, and the first time there is an occurrence of something not indented, that block is over. So this is the whole entire while loop block right here. All right, sweet. So let's go to our game and let's make our game actually playable until they win. All right, that's what we want to do right now. We want to keep going until they win the game. So let's think about this. We want a while loop. We know we want a while loop. And we want this while loop to go forever. We never want them to be able to leave or quit our game, period, until they win. All right, this is a borderline malicious game, but guess what? We don't care. We're soulless game devs, and we're out here to make them addicted. They can't quit. Open their eyes. They gotta keep playing till they finish. All right. What logic do we need in order to dictate that? In order to say keep playing until you are done? Well, when you're done, you have won the game. We've written that logic before. It's right here. It's this if statement right here. See, it says you won right here. So we can literally copy pasta, because we're all about stealing. Make sure you copy and pasta plagiarize. All right, that's what programmers do. All right, so we're gonna copy that logic. Now this while loop will go forever until they've won the game, but we need to put the game inside of it. What do I mean by that? Well, we first, all of this stuff right here, they need to what do you call it? We need to guess every time and like tell them every single time whether they've won or not, whether they've guessed too high, whether they've guessed too low. So what do we do? Highlight all of this and press the tab button. That will tab everything up automatically for you, and now it's all nested underneath the while loop. All of this is a part of the while loop block. All right, all of this is a part of the while loop block now. All of this logic will now loop infinitely. We have one little issue though right now. User's input is all the way up here. Every time the game loops, we do want to get some more input from the user. So we're going to need to copy this line of code here for user's input and move it into this. All right. Now, there's also one more issue that's coming up, which we'll talk about in a second. But now, while the user's input is not equal to the number they need to guess, so we need to actually modify this a little bit from equal to not equal to, because while it is not equal to the number they need to guess, we want them to keep playing until they are correct. All right. We had to put this in here because every time the game loops, we need to get some new input from the user. And we want them to keep going until they've won the game. Now, just like we saw here in our while loop example I gave, when we wanted to end the game, which was at 10, or end this loop at 10, it didn't actually print 10 in here. Same thing in here. If they actually guess the number, it won't actually run this logic and print they won. All right. So this is a little bit of an issue, but it's all right. It's easy to solve because guess what? We got to use our logic here, right? This is the mindset that you have to start like thinking about. This is the thing that takes some people a day, takes some people a month to really like click in your head. All right. And that's the programming mindset of thinking through this logic, seeing it, and being like, all right, while loops, great. This logic won't happen. How do we solve that? Well, this while loop we know for a fact will go forever until they've won the game. So instead of having an if statement here for trying to figure out whether someone won or not, you may think that we might want to add it outside of the while loop. Let's say right here. So when they break out of the while loop, they'll go down here and they'll do this logic. You wouldn't be wrong, but there's a better way to do this. Also, since we're moving this if statement, we need to now make the first elif an if. All right, we got to do that now. So this is not wrong, but there's a more correct way to do things, because we know for a fact if they're ever breaking out of the while loop, they've won the game. There's no way in the world possible. How do we know? Well, we wrote the logic. We said, us, the gods of the computer, literally said, thou shall never end unless you've won. So we know for a fact if they get over here, they've won the game. So we don't need to have an if statement here. We can just say print, you've won, because they've literally won the game if they've ever gotten to this point, ever. So now we have a fully functional game. Did I miss anything? We should have a fully functional, oh yeah, one thing that we have left. But we should have a fully functional game now that will run forever. And it conveniently is a little bit less lines of code. So sometimes doing things correctly will actually be less work and less lines of code than if you did them less correctly. Let me make sure there's no questions. All right. So let's run this and we should see an error that will happen. There we go. That was quick. Let me go ahead and clear this. So this is an error that a lot of beginners like your guys selves will see a lot. And this will happen for pretty much any language that you're in. You'll get some type of is not defined. User input is not defined. What does that mean? What is going on? I think we talked about this a little bit yesterday. So user input is not defined. It means we haven't created that variable yet. What do you mean we haven't created that variable yet? It's right there. Where's my thing? Oh, whoops, wrong thing. Hold on. Whoa, there we go. It's right there. I could see us. We literally made it right there. Correct. We just changed the location because this used to be here at the top, up here. So we used to create it there, but now we're creating it right here for the very, very first time. And we're referencing it right here. We're referencing user input right here before we've created it technically. And that's where this error is coming on. On line 17, it's pointing to this user input right here. But we're creating it on the very next line. All right, so that is the issue. So we need to now create it before it gets to this point so we don't have this issue. So what can we do? We can say here at the very beginning, user input equals, and I don't know, we can just give it a generic number like 0, just to make sure this number isn't the same number that they need to guess, or else the game will be won immediately. All right, so we just need to predefine, that's what we're going to call it, is predefine your variable, so that way your logic will run correctly here. So if you ever see the not defined, it means that that variable doesn't exist. So you most likely need to create it, or something in your logic is wrong. For example, we are creating it, but we're just creating it after we're using it. So if we run this now, you'll see that our game is running. All things good so far. Let's cross our fingers here. Let's guess 5. Oh! We guessed 5, and it said we guessed too low, and we have another prompt here. We can guess again. Let's guess 2. Oh, we're playing the game. Oh, whoops. That's a bug. Let me restart this. Clear. We're playing the game. 5, 2. Oh God, I can never leave. If we do negative, we can see you're too high. Let's do 100. We're too high. I can't play the game. I'm forced to play it. My brain, it's gone. Oh, I won. I've escaped. from prison. I'm free. So we can see now everything is working perfectly. We have a fully functional game now that will loop forever and will never ever end until we get things correct. Of course, you can do Control C still at any time to cancel things. Also, sometimes things are a little sticky per se. So if you press Control C and it doesn't work first, like a space or something prints out, it's best to press Control C like 20 times in a row. I don't know if you guys can hear my keyboard, but every time I try to Control C, I'll usually like press it 2 or 3 times. I mean, you'll usually see right here this Control C get printed out. If you see on every other stream of me doing that, you'll now see this every time, because usually you have to press it a couple times. So now it's just habit for me. So you should now have a fully functional game. All right, we have done some magic here. All right, we have quick recap before we go on to break. All right, quick recap before we go on to break. I was tired of running it. Yeah, I was getting tired of running it every time. Yeah, pretty painful, right? Pretty painful. Now we don't have to. All right, we've been saved by loops. So quick recap. We talked about if statements and how if statements we can make compounding logic using the and or in order to make compounding logic. All right, and if we want to force certain things in our logic to happen first before other things do, we can use parentheses to tell the computer to do this first before running this stuff. All right, and you can also do parentheses here. So now this stuff will run, then this stuff will run, and then they'll be compared with the or against each other. All right, so you can use parentheses to force how things should be computed in the order that you want them to be. So that's important to know because it will become useful as we move forward here. Next we learned was loops. We learned one of 2 loops. All right, our while loop. While loops are great if you don't know when something should end, because they will by default go for infinity. They'll go forever. They will never end. So they're great for things like games. All right, they're great for things like games. We also recapped how when you're moving things around in your program, especially when you're using while loops or any types of loops, pay attention to when you first create a variable, because you may be creating it after you first try to use it. So you may need to pre-make it in some type of default state in order to continue forward with what you want to do. All right, if you guys have any questions, just let me know. All right, yeah, just let me know. I'll actually no, never mind. If you have any questions, post them in the chat. We're not done yet. I know we've gone over a lot, but guess what? We're not done yet. You have a little bit more to learn here. Mostly, we have a second loop to go over, and we need to make this game different every single time. So let's figure out how to do that. All right, it won't be that difficult. Trust me. All right. So if you have questions, go ahead and drop them in the chat, and I'll answer them when we get back in about 3 to 5 minutes. All right, I'll see you guys then. Alrighty. We are back. And we got a little something to do here. We were supposed to do it a couple days ago, but I forgot. Alright, we were too in the weeds and operating systems, so I forgot. Went over my head. So we've been tracking everyone that's been interacting, typing, hanging out, and chatting on the YouTube and Twitch streams, the live streams. Alright? And at the end of every single month, we are doing giveaways. All right, we are doing giveaways. What are we giving away this time? Well, we're going to give away one of these epic collab shirts. All right, we do a lot of giveaways. All right, so if you want to also enter in one of the many other different giveaways we do, if you go over to our site and you click on blog, you'll see our week 3 post here on our blog. If you click on that, you can enter our giveaway to win one of our awesome sweaters, which I have on right now. It's free, completely free to enter. You just need to do stuff like subscribe to our YouTube channel, follow our Twitch, etc., etc. If you like what we're doing here and you want to help support us financially, because doing things for free is not cheap, all right? This is, if you go to college, a $100,000 course. If you go to another coding boot camp or something, it's going to be upwards of $20,000, and they're not going to teach you a fraction of what we're teaching you guys. Not even a fraction of it. So if you donate, you can get certain things like our stickers, our collab t-shirt, and this sweater that I have on here. Additionally, all donations are being met 1 for 1. And when we hit certain pillars, we'll do certain events like streaming for 24 hours straight, shaving my head here live on stream, and we don't need to mention this last one. No one wants to see that, all right? My beard is too precious. That's where my power relies, all right? Alrighty. So, I've been informed 136? Yeah? 136 different things we have logged, different names. So every single day that you've came back and you've chatted, that has been logged again. That has been another entry. All right. So let's go ahead and see here. Let's do a random number between 1 and 136, and Susana will let us know who won. 110. Who is person 110? Please put it in the chat, Susana, and let's see who has won. All right. Any type of Susana. I'm waiting. So for this, we don't have any contact information for you guys. So you need to put a message into the chat if it is you, and let us know so you can claim your prize. If not, so Matthew Favela, we've seen you around a couple times. Yeah, are you here today? You have won this shirt. So post in the chat if you want to claim. Let us know what your Discord name is, or also at us on Discord in the 100 Days of Rootkit. I'll go ahead and put here as one. Is he Matt? Oh, is this you? I think his name on Discord is literally Matthew Favela, so we'll see. I just pinged him. You have until this weekend, so Sunday, to claim your prize. If you do not claim it by then, we will re-roll to someone else. All right. And again, we're keeping track of everyone that is chatting inside of our chat. So we'll be doing this again at the end of this month. So don't worry, there will be more opportunities. Maybe we'll do a surprise one in between. I don't know. I'm spontaneous like that sometimes. All right, sweet. So I don't see any questions from when we were on break. So let's go ahead and chug along here, shall we? Loops. We have another loop we need to learn about. All right, we talked about the while loop. All right, I'm going to comment this out. There's another loop called the for loop. Literally for. All right, what's the for loop? Well, it's going to be slightly the opposite of the while loop. The while loop will go forever, period. The for loop will not go forever. All right, the for loop, you have to define. You have to clearly define an end. All right, that end may be 100 billion. All right, it could be really, really long. But there is an actual measurable end that you know and you can predict, like you know exactly when it's going to end. All right, while loops are for unknown endings. For loops are for known endings. So how would this be potentially useful? Well, let's do something like, we'll show two examples. One will show a list. So we talked about lists before. We're going to bring them back here for a second. So let's say I got my grocery list. Grocery list. And my grocery list is going to be equal to ham, eggs, let's see here, potatoes, that's good enough right now. All right. Well, all right, we got to get some, I don't know, Lunchables in there. Lunchables. I hate Lunchables, actually. I don't know why I put that in there. You guys probably like Lunchables. God, disgusting. All right, so we got our grocery list here. We know how long this grocery list is. It is something that is measurable. We know there's only 4 things in there. We know it has an ending. So we can use a for loop to loop over, like, for example, every item in that list. Again, the keywords are every item in that list. Literally, we can literally say every item in that list. For every item in our grocery list. This is the loop. Remember, at the end of this, we got to add a little but. All right, little colon right here at the very end. And we press enter, it will be tabbed up. So any logic we put now is going to be our loop logic. So we can go ahead and do like a print in here. And so I'm going to just go ahead and finish this up and we'll talk about what the hell happened here after I run this. So here's the whole loop. If I run this, you'll see we get start, hams, eggs, potatoes, Lunchables, and the end. What the hell is going on here? If I told you in the real life, if I gave you in real life my grocery list and I said, please list off each item in that list, you would start listing each item, right? You would say ham, then eggs, and etc., etc. That's basically what's going on here for the for loop. You're making a new temporary variable right here. This is, again, a variable. What are variables? Placeholders for some type of value. Variables can be called whatever you want. You could literally call this cancer. All right. So we're going to need to change this right here to cancer. What is cancer going to be? Well, cancer is going to be every item, one item at a time of our grocery list. So for the first time this loops, cancer will be the first item in our list. It will be ham. Then the second time it's going to be eggs. All right, ham, then eggs, then potatoes, then Lunchables, and etc., etc. Usually devs will name things intelligently, like item. All right, so they'll say for item in grocery list. All right, so for every item in the grocery list, we're going to loop 1 time, 2 time, 3 time, 4 time, until we're at the end, and we're going to perform some logic on every item in that list. Any questions there? Any questions there? So another thing we can do here is also with numbers. So there's another action that we're going to learn about here. So using, let's say, for number in range of 1 to 10. Print number. This is another way we can do a for loop. Range is another action that we haven't really learned about until right now. Range, by itself, you can configure it in several different ways. If you say range of 10, we can see what this does. It will start at, I believe, it will start at 0 and then count up to 10 for you. Or, sorry, it will count up to 10 but not include 10 in its output. If we do something like 1 through 10, we're just specifying we want to start at 1 and go to 10. So you can see here it's going from 1 and going to 10, quote unquote. Technically, it's never going to hit 10. It's always going to be 1 less than this last number. So if we wanted 10 to print out, we could do 1 through 11 here, and you'll see 10 prints out. So this is another way we can make a list and get every number one at a time in this list, just like the grocery list. This was a list of words. This is a auto-generated list of numbers that we can use, all right? Of numbers we can use. And again, this first part is a variable. Variables can be called whatever you want. So we can call it ASDF. This variable will just temporarily be, for that one iteration of the loop, the number of the list that it's supposed to be. So it will auto count for you and it will auto end. Any questions on that? So again, for loops are going to be for when you know how long something is, all right? It could be 1 item long, 0 item longs, or 10,000 items long, but you know exactly how long something is. While loops are for when you don't know when something will end. Does that make sense? What's the difference between the first and the second? There is no difference. These are exactly the same. There is no difference. Grocery list is just an array list. This one, range, is a new function that produces a list of numbers. So if we say my number list and equal to range, and then we print my number list and then change this to my number list right here. Let me cast this into an int, or sorry, into a list so you can see it a little better, because this is not that doesn't make any sense. There we go. So all that's doing is producing this. So range is just a new little function that we're learning about that will automatically generate a list of numbers for you. All right, it will automatically generate a list of numbers for you. Just remember, it's a little bit weird because this you can either do just a single number like 11 and it will auto generate starting from 0. That's the default behavior. It will always start from 0 and count up. But if you don't want it to start from 0, you can say a start and then a stop place for it. All right, start and a stop place. But this behavior and this behavior for these two for loops right here are exactly the same. These are exactly the same. All it's doing is it's going through every item in these lists every time it loops, and every time it loops, whatever item that it needs to be on, it's going to store temporarily into this new variable you're making right here. This is where you're making it, right here. And then you can do some type of logic inside of here with it. Does that make sense? The for loops can be kind of confusing at first. I was confused with them at first, but trust me, as we move forward and we use it more and more often in the coming weeks, it will start to make more and more sense. So if you are a little bit confused, the main thing to understand is while loops will go forever if you allow them to. For loops will not. For loops, you have to give it a very defined end. It can only be looping for a very defined amount of time. What is that defined amount of time? Whatever list we give it. If 11 is the stop, then why isn't that included when you run it? Because it's kind of like this weird behavior we talked about earlier, where it's going to stop one early. All right, so just know it's going to stop one early. If you forget that, don't worry. You'll remember it real quick when you run it and you're like, why is it one number short? Oh, that's right. This will stop one early, right? Just remember this one will stop one early. I forget it all the time, so don't worry. Remember, there's no test on any of these things. When you get the practical, which is your actual programming test, we're going to tell you to make some type of program, to make some type of application, game, whatever it is. You have to go make it, all right? You have to go make it. What we're teaching you right now are just ways you can go about making things. But whether you use them or not are up to you. But you need to know some of these things and that they exist because they will help your life. So, that's the second loop. All programming languages will, not all of them, but a good amount of them will have a for loop. It will not usually look exactly like it does in Python. It will usually be slightly different. And some of them have behaviors that are more like while loops. But we're not in C right now, so we're not really going to talk about that. We're in Python world. So this is all you need to know for Python. Yeah, so stops one early and starts at 0. The default behavior for range, yes. Yeah, so you nailed it on both. So the default behavior for range, if you only have one number, it will start at 0 and count to this number minus 1. So it would be 10. You can also define where it needs to start. So if I say 1, I want it to start at 1. If I say 5, I want it to start at 5. So if I rerun this, you'll see that it now starts at 5 and counts to 10. You can also do negative numbers. So I can do negative 100. It's going to be a massive list. And you'll see it went from negative 100 to 10, right? So this is just where you want it to start and where you want it to end. All right. So let's go back to our game now. So we talked about while loops. For loops are not going to be good for this game because we don't know when the game will end. So we go with while loops because there's an unknown ending. One modification we should definitely make to our game though is some randomness. All right, some randomness because guessing the same number is kind of boring. All right, maybe you want to play this game yourself. Maybe you're making a game literally just for yourself. That's fine. You don't want to, know the answer. So we can include randomness. How do we do that? Well, there's some algorithms we need to learn, and we got to crunch the numbers and do the things and stuff, and very complicated, right? So don't worry. I'll get you guys through it. No, I'm just kidding. It's very, very simple, right? All the math and the technical hoo-ha for it has already been solved. It's already been done for you. It's very, very easy for programmers. So at the very top of our program, we got to do this new thing here. We're going to import. What does import mean? So by default, programming languages will try to run as small and lightweight as possible, right? They're going to run as small and lightweight as possible so they don't bog down the system. So there's actually a lot of code that's built for you by default and included in the Python programming language by default. It's not loaded at all except for the very core functionalities, which we've only been using the core tools, the core functionality. And we've taught almost every single core tool / functionality. We're almost done teaching literally all the base tools and core items. We can extend this by importing extra tools, all right, which is a powerful thing because now it allows you to use tools that are made in the language that you're not using right now. It allows you to use other people's tools to extend your language, and it lets you make your own tools that you can use in your program or give to other people, all right? So how do we import some extra tools here? Well, we want randomness. We want to import some tools to help us auto-generate some randomness. How do we do that? We say import, and we're going to say random, right? Random is a tool set that's built into Python. Why is it called random? How do you know it's called random? Memorization. You gotta learn the other tools that are included by default. There's no way around it besides Googling. So if we didn't know, we can always go to Python, say Python, how to make a random number. That's one way to ask it. I would just recommend saying random number. Python random number. The first link here is going to be for random. And then there's a couple other more links here. The Python docs are not the easiest for new people to look at. So here's what it looks like. Not the easiest. Too many words. All right. So as you get further along in your dev career, you want to look at these. These are going to be the best way to learn about things. But for newbies, Geeks for Geeks is a great site. There's W3 Schools, which we've already recommended before, and Program Miz is also good. All three of these links here are good. How do you learn that? Click around. Figure out what sites you like best. So we'll go ahead and go to the W3 School site, and they'll show us here. This is all we got to do. This is how you get randomness in your program. We got to import random because this is, again, extra core Python tools that we have never had access to, and we have to add. This will make our code in our running program a little bit more bulky, but it's okay because the payoff is now we can have randomness. All right, so let's take the next step here. So inside of random, so if we type in random in VS Code and do a period at the end, so random is kind of, what's a good way to explain it? Random's kind of like the store per se. All right, there's a store that you can go visit and you can walk into. When you walk into that building, when you walk into that store, you're going to see a bunch of aisles of things they have in that store. So how you can walk into that store in Python is by doing a dot. You have to say random, so the location you want to go to, the store you want to go to, because we're importing this, and we're going to do a dot, right? We're going to do a dot after, and that's going to show us the things that are quote unquote in that store. All right. So you can see here all of the different tools we have at our exposure. Now, remember, I talked about this blue icon before. Do you remember that? I talked about this blue icon before. If you guys remember, this blue icon means that it's going to be a variable. So these are just going to be variables. All right. Variables are useful, but we don't really want variables right now. We want functions. What is going on here? Are these, wait a second, I'm confused. Are these the function? Wait a second, hold on. What is the variable icon then? Sorry, the function icon is, all right, now I'm confusing myself. This should be the function, this is a function. This is the function we're going to use. That icon, I think I messed up that icon. Forget what I said there. But the main thing is those icons though are going to tell you when you're looking through stuff, what everything is. All right. These variables will tell you what everything is. So there is a random function, aka an action that we can take called random int. It's just called rand int that we can use. What do they have on this site for their example? They have rand range. So there's several different things you can do. Rand range is one, rand int is one. We're going to use rand int. All right. So if we hover over this, you can see rand int will return a random integer in a range of A and B, including both endpoints. All right. So it's a function, which means we need to do something. It's an action. So we do the parentheses at the end of this. Now this is very convenient, and this one isn't crazy like the rest of them. We need an A and a B. All right. It says right here, we need a range of A and B. So where we want to start and where we want to end. All right. Where we want to start and where we want to end our random range. So we want to start, since they're going to be guessing between 1 and 10. Now the key word here is including both endpoints. Technically, these numbers here are endpoints. So that's telling us that 1 and 10 would be included in that random range. This is important because things like range does not include this endpoint. It does not include 11. It includes one less than 11. So that's why they have that that verbiage there, not to be confusing, but because other people will do stuff differently. So this will produce a random number for us. How can we test this? Well, I don't want to maybe comment out all this code, right? Because it might be, you know, a lot of code here. So what's a quick way we can test this? 1, making a new file. 2, pulling up the Python interpreter, which maybe I'll do that tomorrow. Or 3, there's another action we can do called exit. So if we do exit, that will exit our program immediately right here. This is where a program will exit. So if I run this, you'll see the program just immediately exits. So if we put our little new test code right here, and let's say maybe like a print. So let's print this out, because this will, again, it says return a random integer. It's going to report back a random integer, right? That's what return means. So we can, with that report, we can print that out to the terminal. So let's go ahead and run this. And I got, conveniently, I got a 7, which is what we have. If I rerun this again, I got a 1. If we run this again, I got a 5. If we keep rerunning this, you'll see that you keep getting different numbers every single time, which is super, 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 super awesome. So with this knowledge, we can now just say, we can copy this logic right here, copy and replace 7 with this. And we'll go ahead and remove our print here. And now our game is complete on a new level. All right, it's completely random now. So I can entertain myself. If I play again, if I try to do 7, which was our number before, I guess too high. So let's do 5. All right, let's do 3. I won. It was 3 that time. Awesome. Our game has now been elevated to a new level, which is super, super awesome. And guess what? Most core features that are a part of the extended quote-unquote tool set that you have access to in Python are the same in every language. Every language will have the ability to generate random numbers. Put an asterisk on that, because there's some weird languages that may not. But pretty much any language you use will have the ability to generate random numbers. They will have loops, like while and for loops. They will have variables. Everything you're learning right now is in every other language. Asterisks. It's pretty much in every other language. It's in C. It's going to be in Java. It's going to be in Swift. It's going to be in C#. It's going to be whatever language you want to learn next. It's going to be in there. So by learning one language, you're actually learning them all at the same time. The format may look different. People may be calling things slightly differently in different languages, but the main point is they're going to be there. We'll see that more and more when we get into C. Any questions with this? I learned with the official documentation. I think it's pretty comprehensive, to be honest. You are one wild, wild man. I'll say that. That is super hardcore. I like it. If you guys want, I mean, I will totally recommend, using this, because like you said, it is very comprehensive. There's a lot of words here. It is very much in depth. All right. Also, this makes a lot more sense than what we saw before when we hover over this. All right. This looks a little bit more confusing than the official Python docs. All right. And there's usually an explanation underneath. So yes, this is going to be the best and all. If you're going into the next level of your career, definitely be looking at these, because this is usually going to be the best way to go about it. But if you find yourself being overwhelmed, I recommend these other links also. Again, W3 Schools does a pretty decent job for some of these things. Usually it's decent enough where you can just quickly copy and paste and get the TLDR. But of course, our OG docs will always be the best. That's a great thing to bring up, Brainless. Couldn't follow along fast enough. What questions do you have? Here's the code right here. Let me zoom in a little bit more. Go and ask you guys the questions if you guys are a little bit lost. So while you guys are typing up, again, a summary. Today, we learned that you can make compounding logic statements using and or. Anywhere you can use logic, you can do this. So in whiles, you can use logic, so you can do it in there. In if statements, you can do logic, so you can do it in there. Else if, you can do logic there. Else statements, no, because else statements are just that. So you can use those concepts in all those different places. Additionally, we went over loops. While loops go forever. For loops are defined. All right. While loops, you can use normal logic. All right. For loops, though, they're going to look a little bit different, right? Because we're going to make a temporary variable that's going to store each item in the list for one iteration through it, and it will automatically go through the list for you. All right. For loops, we're going to get more exposure later on, so don't worry about that. But the important thing is for loops are for a defined length runtime. Additionally, or lastly, we learned about, well, I guess we also learned about strings and how we can add variables to them using plus signs or using dot format and curly braces. We'll revisit that, don't worry. Finally, for importing, we learned about importing. Importing is a way you can extend the base language of your program, because by default, not all the tools are included. Because again, that increases size and complexity of runtime. It makes things run slower. So you have to import just the things that you want. That's not the base language. Random is not a part of the base language. So if you want that, you have to import it. How do you know it's called random? You gotta memorize it. All right, that's the only way. You can also do Google searching and find the answers that way. Inside of random, which you can kind of think of like a house, technically it's going to be called an object, and those objects can take actions. How you can get to that action or see those actions is by doing a dot. Or if you want to use the house example, if you walk into the house, dot is you walking into the house, and now you can see everything that's in the house or in the store. A part of that, there was an action in there, a function called ranInt, right? That's the function we wanted. So in a part of this function, if we hover over, we can see there's a little definition here, and it takes one variable and two variables with a little comma in between. We have to say basically the start and the end of our range of numbers we want to get. All right. So we said 1 through 10. So it's randomly giving us a number between 1 and 10. Let's see here. Number they need to guess. Lowest number, highest. Yeah, that should work. That should work, Kamal. Perfect. Let's see here. You type a lot faster than I do. Yep, that's why I said you guys gotta keep working on your typing speeds, because you should ideally have something between 20 and 40. All right, 20 is very much a minimum. You want to be as close to the 40 mark as you possibly can. Being higher than that is very much encouraged. One tiny detail I would suggest is a bit more Pythonic. Your line 20 would be better as correct. Yes, correct. Line 20 right here. Yep. We're not going into super advanced stuff right now because it's more understandable at this point. And Actually, a knot would be required in your case. Yep, we're not even there yet. This is what, day 3 of Python stuff. So we're not going to go too hardcore right now on optimization. Alrighty. Do you guys have any other questions before we end up today's stream? This is your time to ask. Let's see here. See on Discord. What's wrong? It's not working. You can't just say it's broken. You gotta give us the error. That's the only way we can help you out. Alrighty, so just like before or yesterday, pretty much almost every day of the programming days, we're gonna give you a little challenge afterwards. So today's challenge is we talked about formatting a little bit. I want you guys to use your Googling skills. And I want you guys to look up formatting in Python, all right? And I want you guys to see examples of it. And I want you guys to then hook up these two variables here, which are currently not being, I guess they're being used right here. And I want you guys to make it so everywhere we have 1 and 10 is going to be replaced by those variables. And if it's a string, you're going to have to use format to modify those strings in order to use it. So that way, you can easily change whether your game is a guessing game between 1 and 10, 1 and 5, 1 in 1,000, or 1 in a billion. All right, and it should only take me changing these numbers right here. Any questions on that? Any questions on that? And as always, anyone that's a part of the Patreon or the Discord Premium group will be getting these files dropped to them right after the stream. All right, they'll be getting these files sent to them right after the stream. Last chance to ask any questions. Sweet. Tomorrow we're going to... Oh, what are we going to do tomorrow? Tomorrow we're going to go over strings. We're talking about strings. We're going to talk about lists and strings and tuples and dictionaries. We're going to focus on all of them tomorrow. All right? Modifications to the game we're going to make tomorrow. We'll show the answer for how to use formatting. And I don't think we'll be making any modifications to the game tomorrow. I'll have to think about it a little bit more. But we're going to be talking about lists, dictionaries, tuples more in depth. And I'll review my notes and see if we'll add anything else. All right, sweet. I don't see any other questions rolling in. So we'll call that good for today, and I'll see you guys tomorrow.